Okay, so really quickly in this video, I'm just going to go over basically these two essential questions here. So, starting with what is the rotation of a two-dimensional figure? So, say I have, I don't know, a rectangle. A, B, C, D are its vertices, right? And I want to rotate it about some center of rotation, right? And for all intents and purposes, our center of rotation is going to always be the origin. Okay, we're not going to mess with rotations anywhere else. Um, it's possible to rotate about some other center of rotation, but we're not going to worry about it there. So you can see here in orange, let me just do that again. You can see here in orange what I'm doing. I'm connecting one of my vertices to my center of rotation using this right triangle here in orange, right? And the reason for that is I'm going to rotate this rectangle about this center of rotation and maintain this same distance, right, from where I was originally, right? So, for starters, a rotation is when we reorient a figure. Okay, we reorient a figure uh, by rotating it, and it's so difficult to put that into words because rotation is such a simple concept. Um, we reorientate a figure while remaining, we'll say, equidistant from some center of rotation. Okay, and that's exactly what I'm fixing to demonstrate here with my little crappy graphic that I'm drawing. Right, so this vertex D, I'm going to take it and let's say I'm going to rotate it 90 degrees well, this would be counterclockwise. Okay, and we'll talk about that here in a second. Okay, so all that means is now I'm going to redraw and use a different color here. I'm going to redraw my right triangle here. My right triangle has been rotated 90 degrees counterclockwise. And my new point D, we'll call this D2, exists 90 degrees counterclockwise, but still the same distance from my center of rotation, right? And well, by proxy, we know everything else is going to be relative, right? Because this is also still a rigid transformation. Okay, so that means C would be here. And let me not use the same color as the original. I'll use pink. So that means C would be here, which means B would be here, and A would be here. Okay, and we see we've rotated 90 degrees counterclockwise, right? So then that brings us into, well, what is clockwise and counterclockwise? Okay, so counterclockwise, and I'll use blue here, counterclockwise is what we saw just now. Okay, so a lot of you watching this are teenagers, you're learning how to drive, right? So if I start with clockwise, okay, you'll see me abbreviate it as CW. Clockwise would be like turning a steering wheel to the right. Okay, when you turn a steering wheel to the right, you're turning the vehicle to the right. Okay, counterclockwise, on the other hand, I'll abbreviate CCW, would be us turning the steering wheel to the left or turning the vehicle itself to the left. Okay, and the obvious way, right, to think about it is, well, a clock starts from 12, goes 1, 2, 3, 4, so on, right? A clock basically goes to the right it goes clockwise. That's why it's called clockwise. Okay, whereas counterclockwise goes counter to that. Okay, so that does it for this video. If you have any questions over any of these foundational concepts, obviously come and see me. Goodbye.